Okay, everybody, here's section 3.3. Now, this section is a little less complicated than the last section. The last section had a lot of stuff in it, so this one should be a little bit of a breather. So let's take a look. We're looking at dividing polynomials, long division of polynomials, synthetic division, and the remainder and factor theorems. We're going to begin to study polynomials algebraically. Most of our work will be concerned with factoring polynomials, and to factor we need to know how to divide polynomials. You might have heard me say in previous sections, when you are factoring something out, you are actually dividing, and that's what they're saying. So let's look first at long division of polynomials. Dividing polynomials is like the process of dividing numbers. When we divide 38 by 7, the quotient is 5 and the remainder is 3. And I'm actually going to show that here because as I was tutoring a child not so long ago, they were really having trouble with actually long division. So I know it's been a long time. So if we take 38 and we place it on the inside of our division symbol and we're going to divide it by 7. How many times will 7 go into 38? Well, it'll go 5 times. And then I multiply these two and I will get 35. After I multiply, I subtract, and I'm really emphasizing here because when we come up to this next part, we'll be doing the same thing. I'm going to subtract 38 minus 35 and get 3. So now we have 7 and, well, I'm sorry, not 7, 5. Oh, sorry, I was a little distracted. 5 is our, how many times it'll go in? So it's 5 and 3 over 7. 5 and 3 over 7. And when I say 5 and 3 over 7, as they point out down here, I'm actually adding 3 sevens to 5. Okay, so we're going to use this same method to divide polynomials. We're going to take what we're dividing by, multiply it by that quotient, and then add the remainder to it. So for the one that we just did before, we're going to take our what we're dividing by times our quotient. So we have 7 times 5, and then we're going to add our remainder of 3. So now let's look at two polynomials. If I take 6x squared minus 26x plus 12, and I want to divide it by x minus 4. Here we have the dividend, which is 6x squared minus 26x plus 12, and we have the divisor, what we're dividing by, which is x minus 4. So we actually arrange it just like we arranged the last division problem. And then what we're going to do is take a look at how many terms we have that we're dividing by, and that's how we know where we're going to start over here. If there are 2 terms here, I'm going to start with my answer right here. And I'm going to ask myself to find this answer right here. I'm going to ask myself how or what would I multiply x by? What would I multiply by to get 6x squared? So in other words, I already have x, And what would I multiply that x by so that I will get 6x squared? So I'm going to multiply it by 6x. And 6x times x will give me 6x squared. Now, what they show here too is that figuring that out, you could also take the x out here and divide it by 6x squared, and that will also tell you what you need to multiply by. So I put the 6x. Now, I always put it over here, as many as I go over, because that helps me to remember when I'm finished. They like to put it here. I'm going to actually move this over because I think it's going to be easier for you to do if you place your 6x right here. And again, why am I placing it here? Because I have two terms here that I'm multiplying by. So I go over 2. And now the same thing that they're showing you, I'm going to take this and multiply 6x by that. When I multiply 6x by it, I will get 6x squared minus 24. I'm just distributing 6x through this little binomial right here. After I do that, I have to subtract. When I subtract, I'm going to change my sign. So remember, before I emphasized subtract when we were doing the regular number, that's because we do the same here. So we want to change these signs. When we change these signs, that's how when I add these two then, I will get negative 2x. And now I'm going to bring down my next term, which is positive 12. So now I want to take a look at, and again, I'm going to change this. So let me see if it's going to look okay. This is my 6x right here. This is not correct at all. Okay, so that was my 6x. Now I'm going to ask myself, what would I multiply this x by to get negative 2x? What would I multiply x by to get negative 2x? The other thing is I could say, what do I divide if I divide negative 2x? If I divide that by x, what will I get? And I will get negative 2. Either thought will give you minus 2 right here. Okay? All right, so now I multiply this 2 again through this little binomial. So I'm going to take negative 2 because I have a minus here. So negative 2 times x minus 4, and I will get negative 2 plus 8. Now, as before, after you multiply, when you divide, then you have to subtract. So we're going to need to change these signs. And when I change these signs, these two will cancel out, and it'll leave me with my remainder of 4. So my quotient is actually 6x minus 2. And then I'm going to add to that my remainder, which is 4, over what I'm going to be dividing by, or what I did divide by, I should say, which is x minus 4. So the division process ends when the last line of the lesser degree is 1 less than the divisor. So in other words, we started with x squared, and my quotient started with an x. So it's 1 less than the divisor. So what they're showing you here is also another way of saying 6x squared minus 26x plus 12 divided by x minus 4. And my answer to that problem, or my quotient, is my 6x minus 2. And as I showed you, then you take the remainder over what you're dividing by, x minus 4. Now, the other way of taking a look at it is what they showed you on the last slide is, okay, well, how can I know that this is actually equal to it? Well, I'm going to take my quotient, which is 6x minus 2, I'm going to multiply it by what I was dividing by, which is x minus 4. Sorry again for my bad writing. And then I'm going to add my remainder to it. So this will equal what I started with to begin with when I did my division. And that was what the last slide was showing you. Okay, so let me erase my stuff here because they're showing you the same thing. So again, the divisor times the quotient plus the remainder will give you the dividend. Now we're going to look at synthetic division. Now, synthetic division is one of everybody's favorites because it is a simple way of dividing polynomials. We can't always use it because synthetic division only works when you're dividing when you're using a binomial, but it is very handy when you can. So for synthetic division, you're going to use a method of dividing polynomials when you're dividing by a binomial. And we're going to take a look at how to do that. We're going to compare the long division of dividing this by x minus 3 with synthetic division, and you're going to see how much shorter the method is. So here is the long division. I take this, notice I put in a 0x. We didn't really go over that. If we're missing a term, we have to fill it with 0 times that base to the exponent that we're missing. And then, and again, they like to start here. I would have started over on the second one because when you end, you'd be at the very end, and it helps me anyway, know that I'm finished. Okay, so here we have this. Now, look at the difference, synthetic division. Look at the coefficients. I have 2, -7, 0, and 5. So here they are, 2, -7, 0, and 5. So I start out with putting this inside of the bracket with a line underneath. Now, some people write it a little bit differently, but I think this is fine. Now, how do I know that I'm using the number 3? Well, remember, if I have x minus 3 as a factor, my 0 for that, which means if I took this and set it equal to 0 and solved, would be x equals 3. So for synthetic division, I'm going to use my 0 instead. So here I have it. Now, the first thing that I do is bring this first term down. Then I'm going to multiply these two together. And when I multiply these two together, I'm going to put a little dot here, remind you that we multiplied. Multiply those two together. Then I'm going to put that product right here. 6. Now I just add straight down. And I get -1. Now I multiply together, I get -3. And I add straight down, I get -3. Multiply 3 times -3, I will get -9. Add straight down, and I will get -4. This last part right here is my remainder. This is my quotient. Well, how do I know it's my quotient? Well, these are the coefficients of 1 degree less than what I started with. So since I started with x cubed, this will be x squared minus 1x minus 3. See how it's the same as this? And there's my remainder. So a much simpler way of doing it. Let's take a look at an example. Here I have 2x cubed minus 7x plus 5, and I have x minus 3. I see that I'm going to take the coefficients, put them all here. Now notice, since I was missing the x term, this is the same one we did before. If I was missing the x term, I'm putting a 0 in here. This is really critically important, so please star that up and remember that you have to put a 0 in for missing terms. And then again, I bring the first one down. I multiply and put it up here. Then I add straight down. I'll get -1. Then I multiply again, and I get -3. Then I'll add straight down. I get -3. Multiply again, -9. Add straight down, and there's my remainder of -4. This part of my answer, I guess you call it your answer, this part of the problem, I'm going to use are my coefficients for my quotient. So there's my 2, there's the -1 because I have negative x, and there's -3. So that's the same one we did before. I explained it to you on a previous slide, and they wanted to explain it to you, break it down again, so that's good. Okay, so my answer is going to be the quotient times what I divided by. Now remember, that's x minus 3 because I used 3 here. So whatever this is, you're going to say, okay, x equals 3. So if I move this over to the other side, I'm going to subtract it. So my factor is actually x minus 3. That's supposed to be a 0. All right. So let's take a look at what the remainder factor theorem tells us. The remainder factor theorem tells us that if we are dividing by x minus c, then the remainder is that value if I would plug c into that equation. So it's actually also my y value. So here we go with our 3x to the 5th minus 5x to the 4th minus 4x cubed plus 7x plus 3. The very first thing you need to always do when you're looking at these problems is to see, is there anything missing? Anything at all? And when I say missing, I say the exponents should go down starting with 5 and should go to 0. So, is there anything that's missing when I take a look at this? Boy, my writing is getting worse with this thing. But I have 5, 4, 3. I don't have a 2. There's my 1 and there's my 0. So that means I have to add in here my 0x squared when I'm doing the problem. I have to add 0x squared in. So here's my 5, my 4, my negative 4, my 0 for my x squared, my 7, and my 3. I want to take a look at synthetic division because I have a binomial here. So I'm going to use negative 2 because I take x plus 2, x plus 2 equals 0 and solve that. And that'll give me negative 2. Now they also tell you, just remember that the form is x minus c. So if it's positive, then it's going to be the opposite. So they're reminding you here that it's x minus c. So since it is a positive 2, it's going to be negative 2. Either way, doesn't matter. Okay, so now let's use blue. And we're going to bring the first one down. Then we're going to multiply these two and take it up here, put negative 6, add straight down. I will get negative 1. Then I'm going to multiply these two, and I'm going to get positive 2. Then add straight down. I will get negative 2. I multiply together and I get positive 4. I add straight down and I get 4. I multiply together and I get negative 8. I add straight down, I get negative 1. I multiply together, I will get positive 2. I add straight down, and I will get 5. What that tells me is that if I put negative 2 into that original equation, I will get 5. So my point is negative 2, 5. It is also the remainder. The quotient is 1 less than what I started with. So I started with x to the 5th. Now I have x to the 4th, 3x to the 4th, minus x cubed, minus 2x squared, plus 4x minus 1. By the remainder theorem, what I am saying is that p of negative 2 is the remainder when it is divided by this factor. So p of negative 2 is 5. Now the factor theorem is related to it because, and we just showed you that, since we had it, c is a 0 of p, that means your remainder is 0, then you're going to get a factor of the polynomial. So this is only if your last number when you do your synthetic division ends up being 0. So they want us to show that p of 1 equals 0 and use the factor p of x completely. So I put in my 1 value, substitute it into the equation. When I do that, I'll get 1 minus 7 plus 6, and that is 0. So that tells me that x minus 1 is, in fact, a factor of p of x. Now we could have done this by using synthetic division right away. So here's my 1, my 0, my -7, my 6. I want to find out if this is in fact a factor. So I'm going to bring the first one down and then multiply together and bring it up here. Add straight down, I'll get 1. Multiply together again, bring it up here, add straight down, I get -6. My lines are getting crazy. Multiply together again, I get -6, add straight down, and ding, 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 I get 0. So what this tells me is not only that I have a remainder of 0 here, it also tells me that my new quotient is going to be 1x squared. See, I don't have to put the 1 there. Plus, because it's positive, 1x, again, don't have to put the 1, minus 6. So that's my quotient. And notice my remainder is 0. So that tells me, since that's my remainder is 0, that these two things multiplied together would give me my original. Right here. So this would be x minus 1 times x squared plus x minus 6, my quotient and what I was dividing by. Now I want to take a look at this and say, will this factor? And it does. So the very nice thing about it is that now I have all of my solutions to this polynomial, this cubic polynomial I just solved, the whole thing. I see that my zeros are going to be 1, 2, and -3.